The complete story of DeepSeek DSpark. What you call DSpark. Basic definition. What it is and isn't. DSpark is not a new large model, a new foundation model, or a chip. It is a lossless inference acceleration framework, a speculative decoding engine. Full name: a semi-autoregressive plus confidence scheduled speculative decoding system with a complete training toolchain called DeepSpec. R&D team. Jointly developed by DeepSeek's internal harness engineering team and Peking University. Founder Liang Wenfeng is a named author on the paper. Release date: the 27th of June 2026. The paper, open source code, and weights were released simultaneously. It was fully deployed on DeepSeek V4's online services, replacing the older MTP-1 acceleration solution. 2. Industry and company background. Why DSpark was created. 1. The industry's universal pain point. The inherent conflict between two speculative decoding paths. Large language models natively generate text token by token in a serial, auto-regressive fashion. This is slow and has low GPU utilization. The industry developed two types of speculative acceleration: serial drafting, MTP, Eagle 3. DeepSeek's old MTP-1 uses a lightweight draft model to guess n tokens at once, but generating the draft is still serial. The longer the draft, the more time it takes, so speed gains shrink for long texts, and concurrent throughput is limited. The upside is coherent context and fewer errors. Pure parallel drafting, D-flash type, generates an entire batch of candidate tokens in a single forward pass, making it very fast. However, each token is predicted independently, ignoring semantic dependencies. This leads to suffix degradation. The latter half of the sentence becomes incoherent. The main model rejects many of these drafts. Wasting compute power and high concurrency can cause crashes. The industry faced a long-standing dilemma. Serial is accurate but slow. Parallel is fast but error-prone. You couldn't have both. 2. DeepSeek's own business pressure. In mid-June 2026, DeepSeek just completed a $50 billion funding round at a $50 billion valuation. User traffic and API calls surged, putting immense pressure on GPU costs. The main models, DeepSeek V4, Flash and Pro versions, relied on MTP-1 for acceleration online. But throughput became a clear bottleneck in long conversations and high concurrency scenarios. Competition shifted from benchmark scores and model size to inference cost and user response speed. Inference efficiency became a core competitive advantage. The team had limited compute resources and couldn't just throw more GPUs at the problem. They had to squeeze more GPU utilization out of the decoding algorithm. Driven by these two factors, DeepSeek partnered with Peking University to develop a compromise solution, resulting in DSpark goal. Achieve both the high throughput of parallel methods and the high draft acceptance rate of serial methods without changing the main model's output quality at all. 3. Core technology. 3 innovations to fix old solutions. 1. Core innovation. 1. Semi-autoregressive generation architecture. Fixing parallel draft. Suffix degradation. The draft model uses a 2-layer structure, a parallel backbone plus a lightweight serial head. The backbone generates an entire batch of candidate tokens in parallel, ensuring speed. A tiny Markov serial module is added at the end to model the temporal dependencies between tokens, fixing the semantic confusion in the latter half. Compared to DFlash, the draft acceptance rate for long texts improves by over 20%. Many more drafts are accepted by the main model, so no compute power is wasted. 2. Core innovation 2. Confidence-based dynamic scheduling, fixing wasted compute in high concurrency. Traditional methods send all drafts to the main model for batch verification, wasting compute on many low-probability, erroneous tokens. DSpark adds an independent confidence prediction head that evaluates the probability of each draft segment being accepted by the main model in real time. High-confidence segments are sent for full verification and directly reused. Low-confidence tails are cut off early to avoid useless computation. The system dynamically adapts to cluster load. During peak hours, it automatically shortens draft length to prevent GPU congestion, significantly boosting effective throughput under high concurrency. 3. Core Innovation 3. Full compatibility with the original model. Zero precision loss. DSpark is just an external decoding module. It does not modify DeepSeek v4's original weights at all. Mathematically, the output text is guaranteed to be identical to the original v4. There is no speed for quality trade-off. You only need to train a very small auxiliary draft head. The training cost is extremely low. The officially open-source DeepSpec framework allows one-click training of the corresponding draft module. Eve. Performance. Measured on real online traffic. Baseline is old MTP1. Single user end-to-end response speed. Perceived latency. v4. Flash for daily conversation. 60% to 85% faster. v4. Pro for complex reasoning. Code. 57% to 78% faster. In plain terms, a long answer that used to take 8 seconds now outputs completely in 3 to 4 seconds. Server cluster throughput, GPU utilization, core for cost reduction, standard conversation at 35 tokens. S. Throughput improved by 51%. High-speed output at 120 tokens. S for long texts. Cluster throughput improved by over 400%. On the same hardware, the system can handle 3 to 4 times more concurrent API calls, significantly reducing the hardware cost per inference. V. Deployment and open source. Completed on release day. Online deployment. DSpark was fully deployed on DeepSeek's official online services and API on release day. All v4 users have it enabled by default, with no extra steps needed. The old MTP solution was taken offline. Full stack open source. DeepSpec. The entire toolchain is available on GitHub. Draft model training code. DSpark inference implementation. Evaluation scripts. And corresponding weights. Third-party developers can use this framework to add similar semi-autoregressive speculative acceleration to their own LLMs. Industry feedback. Core PyTorch maintainers and overseas inference companies like Fireworks AI proactively published articles about it, making it a key reference for mainstream inference optimization in mid-2026 VI. DSpark's positioning and industry significance for DeepSeek significantly reduces GPU costs for API cloud services, improves user experience, and creates a differentiated engineering advantage for the industry. Breaks the long-standing speed versus accuracy bottleneck in speculative decoding, offering a practical open-source compromise. A trend indicator. Competition in large models is shifting from a pure model capability race to a full chain efficiency race covering both training and inference. You don't need a bigger model. Optimizing the decoding algorithm can already significantly cut costs and boost speed. Number 7. Common misconceptions clarified. DSpark is not a new model. V4 Pro. DSpark is just the original V4 with an acceleration module. The model's knowledge and capabilities are unchanged. It is not a hardware acceleration solution. It's a pure algorithm. Inference layer optimization. No special chips are needed. It cannot be directly applied to all third-party models. You need to use DeepSeek to train a dedicated lightweight draft head for your target-based model. The performance data is compared against DeepSeek's own mature MTP baseline, not against native, unaccelerated autoregression. This makes the technical achievement even more significant.